as we move into Module 7, which is fact and fallacy, we start looking at how science is utilised in terms of testing claims. And we live in a world where we are surrounded by people claiming things. This will make you better looking. This will help you lose weight. This will make you feel better. And of course, in most cases there, people are just trying to sell you stuff. How can you actually work out whether something is true or something isn't? And particularly when you look at things like Instagram and Facebook, which develop algorithms to give you information that you want, or that the algorithm feels that you want. How do you work out whether that information is true or not? And so one of the things we can start there is just this idea of just simply think about, how do you test claims? And so we've got one little one here, a commonly held claim that, the 5-second rule, that if you eat food within 5 seconds of dropping it on the floor, it's safe to eat, there's no problem there. And so you can design an investigation for that. You get a dozen agar plates, you get biscuit in little sections, and you drop them on the floor. And of course 6 are picked up within the 5 seconds, and the other 6 were left for just over 5 seconds, then put in the plates. And it's a commonly held assumption. And how do you actually test this? Particularly of importance for your local cookie monster who doesn't exactly eat very neatly. And of course, what you as a skeptic need to think about is, what's the validity of the experiment? And so in this case here, just this simple one, there's a few issues with validity, because even though it is testing the 5-second rule, the timing between under 5 seconds and just over 5 seconds is a very small time. So you can argue that it's not as valid, or not particularly valid, because there's not much of an effect difference there. Reliability is something you sort of look at after the fact. So if you look at all your agar plates, and if all the agar plates under 5 seconds have similar results, and all the agar plates after 5 seconds have similar results, and you can probably assess that that's relatively reliable. Of course, the accuracy, when we're here talking about random and systematic errors, you could probably argue that that the timing issue, there's a bit of a systematic error, and we probably need to ascertain a better way of doing that. But you can also talk about, well, maybe there's random errors there, like the different parts of the floor might have different amounts of pathogen or different types of pathogens on it. And look, that random error is really impossible to really nut out, to get rid of. And as that last point there, you can make sure all the agar plates are under the same conditions. Now, of course, another really important part there is this idea of sampling. And so you've got two sort of ideas here, the idea of sample selection and sample size. And so we'll look at a couple of examples here. And so this one here is just an investigation looking at coronary heart disease. And so the idea here is that, they looked at 2 sets of people. And one of them were regular joggers, and the other were people who just didn't really exercise. Now, on the surface, you'd say, well, okay, that looks pretty good, and you might be able to get some good data about the effect of jogging on people's coronary health. But of course, one of the problems there is that when you look at the sample and you look at it a little bit deeper, you realise that a good portion of people who are regular joggers also tend to have better lifestyle behaviours. They tend not to do things like smoke as much or drink alcohol as much, or even just eat healthier food with less fats and things like that. And so even in this little experiment here, there is some selection bias, because all the people in one, or the majority of the people in one group, will in general just have better health outcomes than the other ones. The other thing as well, on top of just the idea of selection bias, is how many people or how many samples do you take? We've discussed before the idea of when you're timing things, if you're heating up a beaker of water, You might take samples every minute or every 30 seconds. You tend not to take a sample every second because it's just harder to actually take those measurements. But what you can also have a look there is that if you want to do sampling of a population, now that might be a biological, you could even be delving into the social sciences there, and you want to have a really good sample. And in this case here, you've got 10,000 in a population. How many people should you sample? How many people should you get data from to have confidence in your data? And this is just a little online calculator that allows you to do that. And if you've got a population of 10,000, you sample 370. And of course, this is the sort of thing that also happens when biologists might be doing quadrats or studies of environments. They just look at a small part and try and make judgments based on that. Of course, as well, if you are doing population samples, you also need to make sure that you are doing random sampling. You don't necessarily go to, or you don't just go to one area or one group. So in this case here, if you look here, let's just say all the yellow people are high school students, all the dark blue, dark black people there are all adults. All the blue people before school, all the orange, yellow people at primary school, or however you want to divide up your population. If you want to get an idea of what's happening there, you need to make sure that you've got samples from a whole range of different areas. And this is really important in a lot of things, and it is social science uses this method a lot as well, but particularly biology and then and some earth science do that as well. You've got to make sure that when you are sampling, you may not necessarily just be sampling from a guy like this, white privileged or white or orange privileged person there. And particularly, you don't take health advice from someone who looks as though they need their own health advice. Scientific advice, scientific sampling, you probably want to go to this guy here a little bit more with his whatever blue liquid is going on there. Now, of course, one of the things that people get bombarded with constantly in terms of claims is advertising. And so in this case here, we've got a set of emotive ads. And adverts are simply trying to get you to buy something. And so in a lot of cases there, a lot of science, a lot of studies have gone into the science of advertising and shows that if you elicit an emotional response in someone, they're most likely to feel something and more likely to actually act on that. And so that's why you do get a lot of things, ads saying, can you sponsor a child in Africa? Can you give money to charity? Can you do all this there? What they are trying to do is elicit an emotional response so that you act. It also happens particularly with products for things like babies. They won't say it outright, but they'll make a claim, and you've got to look, you want the best for your baby, use our baby formula. The one on the right there, which is Twiggy, is a well-known English model, mainly from the 60s. I believe at the moment she is still in her 60s, and this is only a very recent ad. And so what you've got here, Olay hired her as a brand ambassador, and one of the things you might notice is that doesn't look much like a woman in her 60s. It's been photoshopped. And so this is trying to elicit a response that if you feel that, well, I'm not even in my 60s and I don't look like that, I need to use Olay. It's trying to use your own feelings of guilt about how people feel about their looks and that, and trying to get them to say, well, I'm going to buy this product because it'll make me look younger, even though that image has been photoshopped. And I believe Olay eventually removed the ad because they admitted they had photoshopped it. And, even though that is a bit smudgy there, you can see that barely, that's smoother skin than you'd get on a baby. Now, one of the other huge areas outside of emotive advertising is health claims. And what we have, the modern Western diet in particular, is in a lot of cases quite unhealthy. There's a lot of problems with things like fats and sugars and salt and all that there. And so it's very advantageous for an advertiser to say our product is actually healthy, because by saying the product is healthy, it's implying that, well, it's good for you, it's better. So in this case here, this is an ad from Heinz. And Heinz at the time were trying to sell this as kids' food. Heinz little kids, 1 to 3 years. And you can notice down the bottom there, 99% fruit and veg. And so there's no preservatives, there's no artificial colours or flavours. It sounds, to someone who's not really paying much attention, that this sounds like a really healthy product, something that you'd want to give your kids to help them grow. However, when you look at the back, and all foods in Australia need to have this nutritional information on the back there, and when you look at it, per 100 grams, so this is, this entire packet here is just under, there's 90 grams, nearly 69%, nearly 70% of this product is sugar. And that's the thing as well, like sugar is a natural component of most fruits. That's why people like fruits. They're sweet and they are naturally full of sugar. And that's fine. However, if you look here where it says in the ingredients, apple paste, apple juice concentrate, berry purees, these products aren't actually made directly from fruit. They're a byproduct of another process. And so there's a whole range of layers of processes that have gone on. And so here where the ad says, our snacks and meals encourage your toddler to independently discover the blah, blah, blah. That's just advertising speak. What it's saying is that effectively what you've got here is a lolly. Lollies are made, confectionery is made from sugar. These are just sugar. And of course, you can look at it the other way as well. One of the things there talks about different pastes and that there. Also realise that even natural or so-called natural organic food or whatever does have a lot of chemicals in it. So it's not necessarily the fancy sounding names. An apple has a whole range of these interesting things in there. So even though there's a lot of scary chemistry in there, that's just what an apple is. And of course, one of the other infamous cases came out several years ago, and there's products like Nurofen. Now, a lot of people use Nurofen or ibuprofen, which is the name of the actual chemical, as a pain relief. It's an effective pain relief. Now, one of the things there that the manufacturers of Nurofen actually started producing different products. And if you look here, they talked about things like Nurofen migraine pain. Now, a lot of people suffer from migraines, and those people who do suffer from migraines, it's a debilitating condition. It really wreaks havoc with whatever you're doing. It's very hard to do anything else. Now, what you have in there is what's in it is the most important thing. Ibuprofen lysine, 342 milligrams. Next there, Nurofen tension headache. It also has the same amount of the same chemical. Nurofen back pain. If you look here in this case here, has actually less. And if you look, that Nurofen migraine pain, tension headache was sold for £2.85. This is obviously from England. Nurofen back pain was actually sold for a higher cost. You also have further down, we have Nurofen sinus relief. Same thing, 34 pence per tablet. Nurofen express period pain, 24 pence per tablet. Whereas you look up here, you've got sort of just the same amount of drug or a similar amount of drug for a lot less. And so in this case here, the company is selling you something. Now, it will help your period pain. It will help your tension headache. It will help your migraine pain. It will help your back pain, because that's what ibuprofen does. Ibuprofen relieves pain in the body, but it's not targeted. It's just a thing where, in general, the drug tends to go to a place where the pain is, because that's where a lot of the blood flow goes to. So what they're doing is selling you, and in Australia, these targeted relief tablets were about double the cost of just buying normal Nurofen or normal ibuprofen. So in this case here, it's a claim, and that is wrong, because it isn't targeted relief. And that's the really important thing for everyone to really consider. The idea that if someone is trying to sell you something, if someone is trying to make a claim about the efficacy of something, be skeptical. Is what they are saying completely correct?